welcome back. In this data example, we are going to look at the different functional forms. Just like what we learned earlier, we have a number of functional forms a part of the linear form or linear relationship. We are going to do Stata example of those non-linear functional forms like double log, semi-log, or polynomial functional forms. First, let's clear the existing data set that we used earlier. Then we open data editor window again. We go to our Excel file and we are going to use this wish data. So wish as a function of education and experience for a number of workers, if I'm not mistaken, 900 over workers. Okay, Control C, and we paste to the Stata data editor window. And in our Stata program, we have these variables. So we are going to regress a function of wish model. Wish is a function of education and experience, but this is the linear function. We learned earlier the linear function is interpreted as straight line relationship between the IVs and the DV, and the way we interpret this coefficient, whatever the measurement of the education and experience variable, the coefficient will give the unit change in the dependent variable wish. So we know that in non-linear functional form, it can be double log. Double log means log variable for the DV and the IVs. Semi-log, either DV or IV, are in log functions. So what we are going to do now, we are going to transform our variables, wish, education and experience, into natural log form. Gen ln wish equal to ln in bracket wish. So ln wish is the name that we are going to give for the new variable, the transform variable. And what variable to transform into natural log? The variable in bracket. So we are going to copy this for the second one, which is education. Here the name is education. Okay. And then we redo it for the experience. Alright. So we have now new variables transformed into natural log. So we can do the double log model, which is regress ln wish, ln edu, and ln experience. So the result that we get here reflect the elasticity relationship between the IVs and the DV. Previously, this is a unit change. These numbers reflect the percentage change in DV when 1% change in the IV. We can also do semi-log, which is regress, ln wish, and then edu and experience. So we are going to look at the impact of one unit change in the IVs on the natural log of wish. So this is log linear model. We get the different coefficient from the double log, and we understand this how this change is going to affect the ln wish. One unit change in education or one unit change in experience, we are going to get 7.8% or 1.9% change in ln wish. So this coefficient reflect the changes in ln wish for a given unit change in the IVs, and this coefficient must be multiplied by 100. On the other hand, we can also do a semi-log regressing wish on ln edu and ln experience. So in this case, we have this coefficient as the size of impact of 1% change in IV, so this impact need to be divided by 100 to get into the value of change of the dV. So we have done with double log and semi-log. We are going to look at the polynomial function. In polynomial function, we have squared variables. So first we generate the new variable in squared. Gen experience SQ is the name that we want to give to squared variable. So experience to the power of 2 is the squared of experience variable. So we get this new variable x per square. So we want to regress which education and experience together with experience squared as the additional IV in quadratic term. So this is a polynomial function, and we know that the impact of experience on which will have a combined effect of this 18 and this 0.04 negative will be multiplied by 2 when we take the dy dx or d which d experience. So we have learned in Stata we can simply generate the squared variable and run the squared variable in the multiple linear regression model. Thank you.